Hey everyone, Mr. Voikin here, and I am just creating this video lesson to supplement the in-class lesson today, as there seemed to be a lot of confusion. So here we go. This is question number 1 that was assigned for the practice work, and it says that we have a graph of this line, and the line is x minus 3y equals -6. Okay, so it says use it to write down 3 solutions to this equation as ordered pairs, so an x and a y. So what you need to do is you need to look at this graph that's here, and we want to find some points that are on this line right there. Okay, so on that line, we need to find some points. So let's start by following from the x equals 1 straight up. Okay, and where it intersects that graph, we would want to go off to the left and see where it intersects through the y-intercept, or the y-axis. And you can see that when x is equal to 1, so right here and right there on the line, that has a coordinate of 1 in the x. But the y coordinate is something like 2.3 or 2.4. So it's going to have a decimal value, so that is not a point that I'm going to want to use. So let's go to the next one. Let's go to 2. So I'm going to come off of the 2, going straight up and intersect the line on the graph. Then come from the point on that line again, where x is equal to 2, and shoot off to the left till it crosses the y-axis. And again, you can see it lands somewhere between 2 and 3, a little closer to 3. But again, when the x is 2, the y value is not going to be an integer. It's going to have a decimal, so we don't want to use that one. So let's go to the next one. We bring 3 straight up where it intersects the graph, or the line that's on the graph, and we're going to bring that straight over again. And you can see that we're quite close to the 3, and there's just some inaccuracy here, but that's the closest we've got to having an integer at the x of 3, and in this case at the y of 3. So what I need to do is I need to prove that. So I'll use this x value right here, 3, that I came off of, and I transpose that up to that line, that diagonal line, and I want to see if x is 3. So if x equals 3, does y equal 3? Well, all I need to do is take that 3 and substitute it into this equation. So I get x is going to be 3. So it's 3 minus 3y equals -6. I'm going to subtract 3 from both sides. Cancels on the left. I got -3y is equal to -9. Divide both sides by -3. That's going to cancel, and I end up with y equals -9 divided by -3, which is a +3. So yes, this has confirmed that 3, 3 is a point that is on that diagonal line. Okay, now I'll just move this off to the left here, and let's take a look for another one. Okay, and I'm going to erase what's on the graph right here. Okay, and we have confirmed with this last one that we have a 0.33 on the graph. Okay, now we've already done 3, 2, and 1. Well, what about 0? So if I go from 0 and I go straight up, it actually looks like right at that point it crosses through the 2. So I would then sort of theorize that at 0 in the x, it should be 2 in the y. Okay, so again, what are we going to do? We're going to go back to our original equation. which was x minus 3y equals negative 6. I know that x is 0, and it looks like it's close to 2, but is it exactly 2? Well, let's substitute the x with 0. So basically what we're doing is eliminating that. And all we have is negative 3y equals negative 6. So I'm going to divide both sides by negative 3. Cancels right here, and I get y equals negative 6 divided by negative 3 is a positive 2. So I just confirmed that that is also a point. Okay, so again, I'm going to just resize this, put it over to the side here, and I'll erase this right there and that. Okay, and we've confirmed that we have a point 0 in the x, 2 in the y. Now notice that I was coming from this point right here, which was the 3, and then I went over to the 0. So I went back 1, 2, 3. So there's going to be a pattern. I should be able to go back 1, 2, 3 again. So let's try negative 3. So I'm saying in this case, x equals negative 3. So I know I'm going to have the point negative 3. What is my y value right there? And we can actually start to sort of make this a table of values here, which I'll do off to the side. Okay, so I've got my x and my y. So what did I already confirm? Well, we started with 3 in the x becomes 3 in the y. Then 0 in the x becomes 2 in the y. Now I'm going to try negative 3. Well, let's look at what's happening here. From 3 to 0, I went minus 3. From 0 to negative 3, I went minus 3. So when I'm going minus 3 on the left in the x column, what's happening on the right? Oops, it's going minus 1. So if I continue that pattern, that means this should be a 1. And if I look back on the graph, if I follow 3 straight up again, it crosses at that point. And if I take that over to the right where it crosses the y, it's going through the y-axis very close to 1. So I'm probably correct. But again, just to prove it, I'm going to start off with my original equation, x minus 3y equals negative 6. I'm now going to substitute the x with a negative 3. So this becomes negative 3 minus 3y equals negative 6. I'm going to add 3 to both sides, canceling on the left. I got negative 3y equals negative 3. Divide both sides by negative 3. And I get y equals 1. And I've now confirmed the third point using math and using the graph and using a table of values. So you should know how all these three forms of the line can be used together in order for you to figure out all the points that are on this line. So this is going to be negative 3 and 1. Okay, I'm going to do question 1 again in a little bit more of an advanced way. And this is going to help you as you move further along in math up the grade levels. So let's just go back to our original equation right here, which is x minus 3y equals negative 6. Okay. Now, what we want to do is we actually want the equation of a line. So this is called the linear equation. And we want to have a linear equation in the form of y equals something. And it's going to be mx plus b. So that's the form that I want this equation to be in. And right now it's not, but we can get it there. by making y the subject of this equation. So let's do that. Essentially, we want that y to stay there, and we want everything else to be on the right side of the equals. Okay, so what am I going to do? Well, the first thing I'm going to do is get rid of this x by subtracting x from both sides. That cancels the x on the left side, leaving me with negative 3y equals negative x minus 6. Now, the reason I put the negative x first is that that's the format that we want. You can see on the equation y equals mx. So I want the x before the b. And the b is this constant right here. Currently it's negative 6. But we're still not finished. I've got this negative 3 right here connected to the y, but I want that y to be isolated. So what am I going to do? I'm now going to divide both sides by negative 3. But there's two things on the right side. So I'm going to divide this one by negative 3, and I'm going to divide this one by negative 3. It cancels on the left, leaving me with just a y equals, now remember there's a number 1 that's in front of there, so I've got negative 1 over negative 3. And if I have two negatives, it just becomes a positive, so it's 1 over 3x. Okay, and that is going to be, now we go to our constant, which is negative 6 divided by negative 3, which is positive 2. Okay, now that I have it in that format, why is this so good? Well, the b is what we call the y-intercept. So that is where the diagonal line is going to cross the y-axis. So what is it in our case? It's positive 2. And look at this. When we go to positive 2, there it is. It's going right through that point. And that point is going to be at 0 and 2. That is where the y-intercept is. Okay, and what does the m mean? Well, that is our slope. Slope is y over x, the change in y over x. And if we look at it, what is it? It's 1 over 3. So it's a positive 1 over a positive 3. So if I find another point on the graph, and I can see one right here at negative 6 in the x, 0 in the y, it tells me that to get back to my line, I'm going to go up 1 unit and right 3 units, or right 3 units and up 1 unit. And if I do that, I'm basically going to be following this 1, 2, 3 and up 1. It gets me back to that line right there, and that will be another point. So I can see right here that we got negative 6 and 0, and now I've got this one at negative 3 and positive 1. And let's go from the other point that's going through the y-intercept. So again, what can I do? I'm going to go up 1 and right 3. So from here I can go up 1 and right 1, 2, 3. It gets me back on that line again. And there's another point right here. And that is going to be at 3 in the x, 3 in the y. So the equation, the linear equation in the form of y equals mx plus b allows me to easily graph this out without doing all that math, just by following, by using the y-intercept and following the slope. Okay, so from this we can also create a table of values. Okay, so I'm going to create a table of values over here, and the x is always on the left and the y is on the right. And what do we have so far? Well, I've got a negative 6 in the x, I've got a negative 3, I've got a 0, and I have a 3. So I should be able to fill in the other side just using my coordinate pair. So negative 6 was paired with 0, negative 3 with 1, 0 with 2, and 3 with 3. So I can go to -9 here because it's jumping by 3 each time, and I can go to 6 right here, and I should be able to easily fill in the rest of this table of values. So you can see that as I'm going up from 3 to 2, it's a difference of 1, a difference of 1, a difference of 1. So I'm going -1 each time, so this should be a -1. And when I'm going down, it's going +1, +1, +1, +1. So it should go +1 again, and I should get a 4 right there. But what happens if all of a sudden it was like a number like 60? Okay, well, if it's 60, I don't want to do, fill in all the little spaces and do all the little jumps, but that 60 is the X value, and I can just shove it back into our equation. And I can use the original one that we had right here, or I can use the one in the form of y equals mx plus b. So let's do that right now. What is y if we're going to multiply the x by 1/3? So the x is going to be 60, and then I'm going to add 2 to it, our constant. So y equals, well, what is 1 times 60? It's 60. 60 divided by 3 is 20. And don't forget this plus 2. And now I get y equals 22. And I would fill this in right down here with a 22. There you go. Hope that helps out. Definitely type of work we would have to be able to do for a level 6/7. Okay, here's question number 3, and it says to draw some axes using these ranges, and I can see that there is an X range and a Y range. So if there's an X and a Y, it means we're drawing a Cartesian plane. So how do you read this? Well, let's take a look at the X, and we're going to read to the left first, and that reads X is greater than or equal to -8. So basically, here's my X, and -8 would be down on this side. And if I read the other way, it's reading X is less than +8, and +8 would be at this side over here. So that means I have a range going from -8 to 8, including those and everything in between. Okay, so what about the Y? Well, again, if we read this and going to the left first, it says Y is greater than -8. So I would sort of have to draw this thing out. I'll move this down a little bit like that. And I'm going to draw the y-axis going up and down right here. Okay, and at -8 is going to be at the bottom, and it's going to be everything sort of greater than that. And what else does it read up here? Well, it says y is less than +8. So +8 would be up here, and it would be everything down from there. So that's how I'm going to draw this, but we're going to have to make it accurate and evenly spaced, and we should be using graph paper and rulers and making sure everything lines up on the little lines that are on the graph paper. It needs to be neat, organized, and readable. Otherwise, there's no point in making the graph. It's useless if it's not actually accurate and precise. So let's make it accurate and precise. So I'm going to make my y-axis come straight down here. I'm going to make my x-axis go straight across here. Okay, and my origin is going to be right at the middle there, which is 0. And what I need to do is I need to go up at least 8 spots. So I'm going to use a thinner line there. 1, 2, 3, 4, 5, 6, 7, 8. And we usually want to go a little bit above that, right, just to create some white space. But this is going to be the the +8 right there. Now, we don't need to fill in every one of those lines. I'd probably be going 1, 2, 3, 4, 5, 6, 7, 8, and people can see what is in between there, okay? Going down, we're going to have negative 1, 2, 3, 4, 5, 6, 7, 8, and I can make a little extra one there. This is going to be negative 8. This is negative 2, negative 4, and negative 6. And moving off to the left, we're going to have negative 1, 2, 3, 4, 5, 6, 7, 8. Again, I would just sort of give myself an extra one. That is negative 8. That's 2, 4, and 6. And moving to the right, we're going to have 1, 2, 3, 4, 5, 6, 7, 8. And one extra one. And this is going to be 8, 6, 4, and 2. Okay? And I really don't need anything much past that. I do want to indicate that this graph is going to continue in all directions forever and ever. But those are the values we're looking for right now. Okay, now it says use a table of values to find 3 points on each of the lines. So essentially what a table of values is, again, is an X and Y chart. X on the left, Y on the right. So we're going to do letter A right here, and it says X minus Y equals 6. So I want to choose points that are going to be on the graph, and we usually start off with the X. So I'm going to choose, say, the number 4. So X, when X is 4, what is Y? Well, again, I'm going to take that equation, the original one, which is X minus Y equals 6. I'm now going to substitute the X with a 4, so it becomes 4 minus Y equals 6. I'm going to subtract 4 from both sides, and I got negative Y equals 2. And I know that if negative Y equals 2, then Y is equal to negative 2. So that means when X is 4, Y is negative 2. So that is definitely a point that falls within the range there. So I'll just resize this and move it out of the way right now, and I will plot that point. We'll use red in this case. So I'm going to go over 4, down 2, and I'd probably label this one as point A. So that's point A right there. So it says to find 3 points on there. So let's go find another point. What about 0? So I'll go to a 0 right here, and I'm going to go back to my original equation. So X minus Y equals 6. And if X is going to be 0, we can just get rid of it, which means when X is 0, negative Y equals 6. Well, if negative Y is 6, then Y equals negative 6. So it's 0 and negative 6. And those points are definitely on there. So if I go down 6, right there is going to be another point. That could be point B. Okay, now I basically have a line that should come from here through point A and continue off in that direction. And same with down the other way. Okay, so that is going to be our line that will continue forever and ever off to the right and up and down to the left and down. So let's take a look at another point that's on that graph. Well, I see one right here. That looks like when it's at 8 in the X, it should be 2 in the Y. Well, again, what am I going to do? I'm going to go to my original equation, which was X minus Y equals 6. I said if 8 is the X, let's calculate Y. So 8 minus Y equals 6. I'm going to subtract 8 from both sides. I got negative Y equals negative 2. If negative Y equals negative 2, then Y is equal to positive 2. So this should be a point 8 and 2. So that's the point that I have right there, and we'll call that one point C. And I'll do one more just to prove a point. Funny joke. Okay, move this out of the way. Let's take a look at the graph. Oh, what's going on there? Easy. Okay, so let's take a look at the graph and see if we can find a point that should work out. Okay, well, here's another one right here. Right there, which is -2. I forgot my negatives right there. At -2 in the x, it looks like it's -8 in the y. Well, again, what do? Go back to my original equation. X minus y equals 6. Let's substitute the x with a -2. So -2 minus y equals 6. Add 2 to both sides, and I get -y equals 8. If -y equals 8, then y equals -8, and I've just confirmed that point again. So at -2 in the x, it's going to be -8 in the y, and that could be point D. Okay, now the only thing I would say here is we're sort of bouncing all over the place. The table of values actually looks very disorganized. We usually keep this in some order. Okay, so I'm just going to redraw this table of values as it should look. And we're going to always start with the negative number, which was -2, followed by the next one, which is 0, and then 4, and then 8. The -2 is a -8, the 0 was a -6, the 4 was a -2, and the 8 was a 2. Now we're missing a couple numbers in there. You can see when I skipped down, I went from -2 to 0, which is add 2. And then all of a sudden I added 4, and then I added 4. So really I should be able to sort of move these two down and put in another +2, which should be 2. Okay, now let's look at the pattern on the other side. -8 to -6 is +2. So I should be able to +2 again, which means if x is 2, y should be -4. And let's just take a look at that. Well, here's the 2. Let's draw that straight down, and you can see where that lines up. It actually does match up with -4. So that's a true point. And I should be able to also move this 8 down and the 2 down and fill in another number right here, which is 6. And again, if you look at the pattern, it's going +2, +2, +2, +2, +2. And on the other side, it's also going +2, +2. And so -2 + 2 is 0. So there should be another point at 6 in the x and 0 in the y, and there it is. Okay, so essentially you just have to do the same thing with example B, example C, and example D. Good luck. Okay, let's take a look at question number 4. We have a graph. You can see we've got an x and y axes with 3 different diagonal lines that are plotted onto the graph. They are labeled as line A, line B, and line C. It says that in a different order they have these 3 equations right here. So one of the equations is 2x minus 6y equals 12. The other one is x plus 2y equals -4, and the third one is x plus y equals 2. So our task is probably going to be use different strategies to figure out which one of those lines is A, which one of those lines is B, and which one of those lines is C. Match them up with the equations. So the first question says, which line does the point 2 and -3 land on? Okay, well, I don't really need to do any math in this case because I can just use the actual graph, the Cartesian plane itself. So x is 2 and the y is -3. So I'm just going to jump over to x is 2. Now there's a point right there, but that point would be 2, 0. And that's not the one that we're looking for. So what I want to do is go from there straight down And if I was to come off of the 2 straight down, you can see that we're going to go through 2 lines. So all 3 of these lines have a point at where x is equal to 2. We get the point A, which is right there, which is 2 comma 0. On line B, it's right down here, which looks like 2 comma negative 3. And on line C, it's right there, which has the coordinates of 2. And in this case, we don't actually land on an exact value. If I go off to the left till I cross the y, it's somewhere around 1.4. And that can be calculated using the actual equations. But for right now, it says which line does the point 2, negative 3 land on? Well, 2, negative 3 is right there, and that is on line number, or letter B. Okay, let's take a look at 4B and 4C. So it says that which equation is x equals 6 and y equals 4. Well, that's pretty simple to do. We just need to make an ordered pair out of that information where x is 6 and y is negative 4. Now we just need to go to where x is 6 and draw a line straight down. Go to where y is negative 4 and draw a line straight across. And wherever those two sort of meet, that is where that point is, and we can see that that is on graph A. Okay, and question C says that we have an ordered pair, but it's going to be the solution to both of these lines, 2x minus 6y equals 12, and x plus y equals 2. So what that means is that it's going to be at a point that where 2 lines cross. And where do we have those points? Well, I've got one point right there, I've got one point right there, and I got one point right there. Whoa, those are very big dots. Okay, so now I'm just going to have to sort of punch those numbers in and see which ones make it true. Well, let's take a look at the bottom right one first. And seriously, I haven't done this question yet. I'm just hoping that's the right one. Sometimes you're lucky, sometimes you are not. So if I look at this point down here, what are the coordinates? Well, it's 6 in the x and negative 6 in the y. So what I need to do is take an equation like this one, x plus y equals 2. And I need to take the x, which is 6, and the y plus negative 6. And does that equal 2? Well, no. X plus negative 6 is 0, and 0 does not equal 2. So that tells me that that cannot be one of the solutions. So let's go to one of the other lines. I'll go to the next one up at the top there, which happens to be 3 in the x, and it looks like a negative 1 in the y. So again, I'm going to substitute this x and y with those values, and when I calculate out the left, it should equal to 2. So what is x? X is 3 plus negative 1, that equals 2. So that's true, but it's only true so far for that one line right here. What about the other line? So we're going to do the same thing. I'm going to substitute in my original equation 2x minus 6y equals 12. So I'm going to replace the x with a 3, and I'm going to replace the y with a negative 1, and when I calculate the left, it should equal 12. Well, 2 times 3 is 6, and negative 1 times negative 6 is positive 6, so 6 plus 6, and that does equal 12. So in this case, that is also correct. Okay, so let's take a look at part D. It says line C crosses the x-axis. So the x-axis is right here, and it says line C goes across that at 6, 0 right there. Okay, and it says this is called the x-intercept. So at the x-intercept, what do we know? Well, at the x-intercept, the x is wherever it's crossing, so 6, but the y is always going to be 0. So that means that the y-intercept, the x will always be 0, and it's where the diagonal line crosses this y-axis right here. So there are 3 lines that are crossing this y-axis, and we have a point right there and a point down here. So what are the coordinates of this line A at the y-intercept? It's going to be 0 in the x2. And you can see line B and C, they're crossing at the same point on the y-intercept. So it's going to be 0, -2. Now let's take a look at this equation of the line they want us to use, which is x plus y equals 2. So at the y-intercept, they're saying here, what do we know about x? It equals 0. So really, I just eliminate that. So what I get is it will be the line where y equals 2, and that is this one right there, or line A. Okay, and part E says, which equation is x equal to 30 and y equal to 8? So what we're doing is we're looking for, again, an ordered pair where it's 30 in the x, 8 in the y. It says, now how do you know, how can you determine which line it is without doing any calculations? Well, if we look at line A and B right here, they are both going down into the negative y. So, and they're going to the right in the positive x. So as x gets larger, the y is actually going more and more and more negative. So it cannot be A or B. If we look at line C, it's sort of shooting up in this direction right here. So as the x increases, the y also increases, and it's going into positive sort of territory. It's up here in quadrant number 1. So the only possibility is line C, because it is going to be the only line that is in quadrant 1 as we move further right and get all the way over to 30. All right, question 4F is definitely quite challenging. I'd like you to try it on your own, and we will go over it in class together. And yeah, it's a very interesting question. So if you're up for a challenge, let's see if you can get it done. Okay, we're going to move on to question 5. And I already sort of hit this point when I redid question 1. Finally, we have this line, or this equation for a line that's in what we call slope. Let me just change to a thinner pencil. Slope intercept form. So this is the slope intercept form of a line, and it's in the form of y equals mx plus b. And this is the equation for a line, so it's a linear equation. Okay, now we have to sort of know, well, what is y? Well, y is a point on the line that this equation will form, and so is x. X is also a point. They will be an ordered pair found on that line, so that's going to be some x value and a y value. And there's basically infinite points along any line. Now we have these m and b variables, and what are they? Well, m is the slope. And what is the slope? It is rise. I'm just going to move up over a little bit. Rise over run. And what is rise? Well, rise is going up and down. So that's the change in the y values over the change in the x values. And this will become important later if we're trying to plot points on a graph. And what is B? Well, B is what we call the y-intercept. So that's where it crosses the y line. So at that point, we know that x is equal to 0 at that point. So you can always find the y-intercept by using the value 0 for x. Okay, so now that I know that information, it says to graph this line that is y equals 2x plus 7. So I'm going to make a quick little graph right there. So there's my y-axis and here's my x-axis. Now if I'm going up 1, 2, 3, 4, 5, 6, 7, 8, so that's going up 2, 4, 6, and 8. Now if we look at B, what is B right here? Well, that is the y-intercept. What did I say that is? That's where it crosses the y line, the y-axis. And that happens to be right there. Okay, so that's really easy. Now how do I find some other points? Well, I can randomly choose some values of x, put it into a table of values, and it might turn out that the x and y are both integers, but possibly not. So in this case, we can just take a look at the slope. Now, this has a slope of 2, but remember, slope is rise over run. It's the change in y, how far you're going to move in the y direction over how far you're going to move in the x direction. But there's only one number there. But remember, any integer can just be put over 1. Okay, so really that 2 is a 2 over 1. So if I put a 2 over 1 down here, it's a positive 2 and a positive 1. So that means that I would move up 2 and right 1 to find my next point on the line. Okay, but you see, if I move up 2, I'm going to actually, 1, 2, I'm moving off of the graph. I don't have any more graph to move up 2 and over 1. So if you think about it, well, it's a positive 2. How else can you make a positive 2? Well, negative 2 over negative 1 is also positive 2. So what that means is negative 2 means go down 2, and negative 1 means left 1. So basically what I'm going to do from that point, the y-intercept, I'm going to come down 1, 2, and then I'm going to move to the left 1. That's going to be my point. Then down 2, left 1, down 2, left 1, down 2, and left 1. And then basically I can join those lines, or those points, right here. So I'll make those points really quickly. Zoom in here. So I'm going to go down 2 and over 1, 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 and down 2 and over 1. And like I said, we can take a line and go right through all of those points, like so. And an arrow goes on that end, and an arrow goes on that end. And that is the graph of that line. Now, we would want to, finish off labeling all of our points if we wanted to complete this properly and also give it some values. And there we go. All right, so let's take a look at the question again. You can do B on your own. That's pretty easy. Just go back and compare it to some of the previous graphs. But let's take a look at C. It asks us to rewrite this equation. And again, I already went over this before. So we have 2x plus 3y equals 6. So I'll just come down here. We have 2x plus 3y equals 6. Now remember, what we want to do is we want to take that and put it into the slope-intercept form, which is y equals mx plus b. So we want to make y the subject of this equation, which means y needs to stay right there, the 2x needs to move to the right side of the equal sign, and the 3 also needs to go. Okay, now we still can use this equation in the form that's on the left, even to find the y-intercept. Remember what we said up here, the y-intercept is when x equals 0. So all I'm going to do is substitute the x for a 0. So this becomes 2 times 0 plus 3y equals 6. Well, 2 times 0 is going to eliminate that. So I'm really down to 3y equals 6. So I would divide by 3 on both sides, and I end up with y equals 2. So that means when x is 0, y is 2. That will be our y-intercept, which will again be this b value in the slope-intercept form of this equation. Now, it's actually asking us to put it into that form, so let's do that. Okay, so what did I say I want to do? Y is going to stay there, everything else needs to go. So I'm going to minus 2x from both sides. On the left, they're going to be canceled out, and I have 3y equals, now I've got a 6 and a negative 2x over there, so I might as well put it into this form right here with the coefficient and the x, or the mx first, followed by my b. Okay, so I'm going to write this as negative 2x, and this is a positive 6, so plus 6. B can also be negative, of course, so this is really plus or minus b. Okay, and as you can see, it can be a positive m or a negative m value as well. So now that I've got the negative 2x on the right hand side, I still have this 3 here that I got to deal with, so I'm going to divide this side by 3, which means I need to divide the other side by 3, but I need to divide every term on the other side by 3. So here's my first term, I'm going to divide it by 3. Here's my second term, I'm going to divide it by 3. So on the left hand side, 3 divided by 3 is 1, so we have what we want. We've got the value of 1y is going to equal, now it's negative 2 over 3x. Okay, so in this case, I'm just going to leave it like that because that's my m value. Negative 2 is going to be my change in y, and positive 3 will be my change in x. Okay, don't forget we need to have that x value there, and it's going to be 6 divided by 3, which is 2. So that is that equation in the slope-intercept form. Okay, and why is it called the slope-intercept form? Well, because it tells you the slope and it tells you the y-intercept right here. So again, if I wanted to graph this, it's quite easy. So I'm going to draw a line for my y-axis, draw a line for my x-axis. I can see that the y-intercept is at 2, so if I went up 1, 2, 3, 4, 5, that point right there is 2, where my y-intercept is. And what does the slope tell me to do? It tells me to go down 2 and right 3. Okay, so I'm going to go down 2 and right 3 in 1 second. Here we go. So I'm going to go down 1, 2 and right 1, 2, 3. So I've got a point right there. I'm going to go down 1, 2, and I'm going to go right 1, 2, 3. So I'm going to have a point right there. And I would go down 2 and go right 1, 2, 3. So I have another point right here. And remember that the slope is negative. So we've got two values we can use for the slope. We've got m can equal negative 2 over 3, in which case go down 2, right 3. But m can also equal positive 2 over negative 3. Both of those are negative slopes. So on the second one here, it's saying to go up 2 and left 3. So from here, I'm going to go up 2 and left 1, 2, 3. Put a point right there, and I'm going to go again up 2 and left 1, 1, 2, 3, and there's my final point. And you can see that these will all line up. So going from this point straight through everything, I get a line that goes through all points.